1, 2. Can you hear me okay if I just leave it hanging like that? Maybe. Okay, we're at 9:05, so I'm going to get started. Just to let you know in general, the way that we're going to be working with the lectures and things is we're going to be starting at 5:05 and finishing at 5:02 because that's how the lecture recording system here works. Everything we're going to do in the lectures is going to be recorded so people can come back and see it later and stuff like that. Having said that, I should probably introduce myself and other things. Welcome to COMP1511, which is Programming Fundamentals. It's going to be the first programming course for all of you here. For a lot of you, for probably nearly all of you, this is not going to be the last programming course you do. But this is the one that teaches you the basics. I should start off with that first question. So there's a Slido up here. You can join it if you want. By the way, if you are going to post anything there, please keep it above board. Like there was a comment up there before that I do not appreciate. So we want to keep that kind of stuff under wraps, all right? Like, at some point, I will maybe have to moderate this, but I would hope that I don't have to do that. Okay. So, yeah, maybe it was, I don't know, but we'll let that question go for now. Yeah. So, can you please not post random crap there? Okay, I'm just going to ignore that for now, and I'm only going to look at the questions when they come up. But that is a place where if you have a question and you want to ask it, you can ask it there. Hello. Anyway, let's go on to the actual lectures. You know what I'm going to do for the moment? I'm just going to do this for now. Oh, wrong one. No. That's not what I wanted. There you go. Now you have to listen to me for a little bit. Okay, so today I'm going to just give you a sort of an intro to what COMP1511 is going to be, how we're going to run the course and things like that. We are going to do some programming today as well. Pretty early start on the programming, but then we're going to be ramping it up pretty quickly into sort of more genuine programming. But let me actually just launch into the lecture and then we can talk about what we're talking about. So today, we've got a 2-hour lecture. The way I'm always going to do this is I'm going to lecture for about an hour. I'm going to take a 5-minute break in the middle and then lecture for about an hour afterwards. It's pretty hard to speak for 2 hours straight. It's pretty hard to listen for 2 hours straight, so we're always going to take a break in the middle. First couple of weeks, as you are one of the biggest first-year cohorts that exist at UNSW, we're probably going to have people coming in and wanting to talk to you and things, because we've already had a couple this morning, which is kind of cool. There's a lot of stuff to do at UNSW, so it's cool to get to hear about some things as well. So I'm going to talk to you about, actually, I will introduce myself. It's in the next slide, but anyway. We're going to talk to you about what COMP1511 is, what we expect that you'll be able to learn by the end of the course, how we're going to structure it, how we're going to get help in doing things. The second hour, we're going to have a look at some of the idea of what computers are. I mean, like, I know nearly everyone's got one on their lap or on the desk in front of them at the moment. You've probably all got smartphones in your pockets that are basically computers as well. But we are going to think about if we are going to get computers to do things for us, if we're going to get them to be, running interesting things, programs we call them, how we want to think about them. Give you a little bit of a history about computers as well, which is always fun. Anyway, what I probably should have started with is, who is teaching you? My name's Mark. I'm one of the 2 lecturers here. The B-stream lecturer is obviously, I don't know if you can tell which one is me, but if anyone's watching the recordings rather than being here in person, I'm the picture at the bottom. Andrew Taylor is the picture at the top. He is the other lecturer in the other stream, because there's so many of you, you don't actually all fit in one lecture theatre. We'll see how we go. By the end of term, we may compress into one stream, but we'll see how we go on that. You also have a lot of tutors who are working on the course. There's actually too many of them to mention, although we do have at least one of them here, Tom. Oh, wait. Alvin's at the back there. Is any other tutors in here? Okay, so there's just 2 of the tutors are here. So you can say hi to them if you want. Who's already had a tutorial? All the Monday tutorial people. Okay, there's going to be a significant percentage of people who had their tutorials already. You've already met your tutor. You've probably done a little bit of introductions and things. And maybe a lot of what I'm going to talk about today is actually going to be stuff that you've already seen in the tutorial. But as we go forwards, we're going to be sort of trying to cover the lecture content in the tutorials afterwards, but we didn't really want to waste the Monday for everyone who was enrolled in the Monday tute, so we gave you a Monday tute anyway. If you need the course webpage, I've listed it there. I think people should probably maybe have been able to access this already. There's a link to it via UNSW Moodle. You can use this link. We're going to be using that for delivering all the content to you, so all the tutorial content and stuff. The slides that I'm going through now are on that website, so you can look at them in advance. I'll usually have them up on the weekend, so you've got a couple of days to look at them before you actually come here into the lecture if you want to. There's also a course forum. If anyone hasn't received an email to the course forum, you can contact us to let us know, and we can put you on the course forum. When I say contact us, I will show you which email address to contact. Oh, wait, no, it's right there. Who wrote these slides? Very smart, knew what they were doing. OK, that's the email address to contact us. It's a good one because it contacts a bunch of us who work on the course. If you were to perchance find my personal email address and email it, there's not actually a good chance that I'll reply because I have a lot of other work happening at the uni and I end up having to do that a lot. Okay, so welcome to UNSW and welcome to programming. Hands up, who is in their first year at UNSW now? Okay, nearly everyone. All right, so I shouldn't just say welcome to COMP1511 or welcome to programming and stuff. I should say welcome to UNSW. So welcome to, I think someone said this years and years ago, welcome to the worst 3 years or the best 5 years of your life. Wow, that doesn't make any sense to you yet. Okay, it's 5 years long if you fail a lot of subjects and like maybe don't do everything the right way along the way, and then it's a lot more fun, but I didn't say that. So what I like to say sometimes, and this is something that we think about because actually, who's straight out of high school here? Who's just coming straight out of high school? Okay, that's nearly everyone. So this advice is probably going to be relevant to a lot of you. The way I like to think about high school, it's not the best way to think about it, but I do anyways. High school is a little bit like a prison. You're super institutionalized, right? You're super like, you've got to be there at exact times, and then you have to be in exact places. And if you're not there at the exact time, the exact place, someone goes looking for you. And someone says, okay, there's a problem here. You need to be in those places you're supposed to be in. University is much more free like that. You can actually choose what you're going to do. You can choose how you're going to do it. You end up in control of your own education in a way that you weren't in high school. So in high school, you kind of get railroaded into particular paths of doing things. At university, it's like really, really open. So you would have noticed this because most of you just came straight out of high school. In high school, you get the choice of like, I don't know, maybe 10 different subjects or something. And then when you're applying for university, there's like 300 different courses in like so many institutions that are so much bigger than any of your schools were. And suddenly you've got all this choice and you're like, I have no idea what I want to do. I mean, I'm sure there are people in here who are like, nah, mate, I knew exactly what I wanted to do. I wanted to do computer science. And welcome to you. But welcome also to the people who are saying, I'm not really sure if this is for me. And I'm not really sure if this is definitely what I want to do in the future, but I'm willing to check it out. One of the funny things about university is if this doesn't work out for you, if you end up not liking computer science or not liking the degree you're in, you can just walk out these doors somewhere and you could throw a rock. Don't do this, by the way. But you could throw a rock and then you'll just hit a random building that has a completely different focus. You could throw a rock that way and hit biomed, I think. Someone was asking about that on the Slido before. And you could just be in a completely different degree or a completely different kind of way of studying or different things you want to learn about the world. You can throw a rock that way oh, it's not the arts building anymore, but I think it is still one of those ways. And then you could say, I don't want to do computing anymore, I want to make films, and you can learn how to make films here, right? So there's all these options, and everything's free to you. So I think one of the things to think about now that you're at university and you have this freedom is not only do you have the freedom to do what you want to do, but you have the responsibility to look after it yourself. So no one's going to chase you. If this is the last thing that you attend at COMP1511, I'm not even going to notice until, for example, you don't turn up for the exam and then you fail the course, and I'm like, oh, I don't know who that person was. There are 700 of you or so with 700 of you, there's pretty much no chance that I'm going to meet that many of you or get to know you individually and things like that. Your tutors will, though. Your tutors probably will. But no one's going to say, you didn't turn up, where are you? Or call your parents and say, hey, so-and-so did not turn up to university today. It's not like that anymore. We have crossed over into adult education now, so you're all adults now, and you can deal with your own responsibilities, and they will be your own responsibilities. So you get this kind of double-edged thing. You get to choose whatever you want. You can come to as many lectures as you need. You can come to as many tutorials as you need. You don't necessarily have to go to all of them. I mean, I would suggest it still. I mean, I'll get really lonely here if no one turns up. I don't know if I'll even deliver the lecture. But the trick is that you're in control now. So not only do you get to choose how much you commit to, it's your responsibility now to decide to commit to things or not. So that's a little bit about what study is going to be like here. For a lot of you, this is going to be the next 3-4 years of your life, so it's a different way of doing things from high school. It's good to sort of get used to it and to realize that you're not locked in a way that you were before. You've got a lot more freedom now. You may notice you've got electives and you can just grab subjects from other parts of the university and stuff. When I was talking about filmmaking, you can do a course on filmmaking within the degrees you're in. They're a lot of fun, actually. I did one little one when I was here. Okay, so let's talk about programming itself. So this is where the meme comes in. I like to think of programming as talking to computers. So one of the things I could do right now is I could talk to my computer. This joke is going to get worse and worse the better speech recognition gets. But I could talk to my computer and say, hey, computer, can you write me a program that organizes all of the lecture slides and puts them in a nice format for everyone to read? What does anyone think my computer's going to do when I say that? Feel free to put your hand up if you want to. Yeah, the computer's going to say just what you did. It's going to say nothing, and it's going to do nothing because I just tried to talk to it like a human, and I just said, hey, do this thing for me, and it's not going to do it because it doesn't understand English. Although honestly, I think there are several computers in our phones and stuff, and the what is it there? The Alexa that's sitting in your house recording every personal conversation you ever have. They're not too bad at understanding English, but in general, a lot of the things that we want to do with computers, they don't necessarily understand the language that we use. So what we need is what we call a programming language. A programming language is like an intermediary. It's like if I go up to someone, say I'm on holiday in France. I wish, no, I'm here lecturing instead. But if I was on holiday in France and I went up to someone and I said, hey, can you help me get somewhere? And they say something in French, and they don't understand me, I don't understand them, but maybe, what if there was a language we both understood? So what if I happened to speak German and they happened to speak German, and then suddenly we could communicate? The computers are a bit like that. They can understand certain things, and we can understand certain things, but we need a bridge between the two of us, and the bridge between us is going to be something along the lines of a language that we can both understand, and those are going to be our programming languages. We're going to cover one programming language here in this course. It's called C. It's one of the probably most historically significant programming languages in existence, so it's a good one to learn. The other thing we're going to learn about programming is once we have that communication bridge, once we have the ability to talk to our computers and have them understand us, and once we can train ourselves into understanding the language itself that we're going to talk to the computers, we need to then figure out what problems we want to solve. So we want to decide how are we going to, now that we have this communication bridge, how are we going to decide what it is we want the computers to do and how we want the computers to do it. And this comes into a bit of sort of logical thinking, a bit of if the computer has a few specific things that it can do, and we're going to build up your vocabulary in this language of the specific things a computer can do. How do we use those specific things to piece together a solution to a problem? So if anyone loves like little puzzle games and stuff like that, you may find a lot of that experience and ideas are going to cross over into programming. The other thing that's interesting about computers, I will talk about this a little bit later, is that we're not necessarily going to just be giving the answer to computers. And this is one of the things that makes programming such a powerful thing, and probably one of the most important things happening in the world right now is what we can and can't do with computers. Is we don't necessarily give the computers the answer to a problem, we give the computers a procedure to follow with which to answer a problem. And that way we might be able to get computers to answer problems that we can't answer at all. And that's really going to be one of the biggest things with computers. It's one of the things that we're going to get that allows us to use computers to do all kinds of things. And you're going to take your first steps on that journey in the next 10 weeks with us here. We're going to hopefully get you by the end of this understanding a lot of the basics of programming so that you can get going on how computers work. All right. Details of the course. I'm going to talk an overview of what we're going to do, and then also I'm going to go through and look at the precise course format and give you some details on those things. I'm not going to go too deep into all of those. I'm going to give you an overview, and if you want to go deeper, you can look at the course outline. The course outline's on the course webpage. I think it's on one of my slides here anyway. So as I said, a few of the things that we want you to know about is how to think when programming. So that's an interesting one, because what we're doing as programmers and what we're doing as software engineers or data scientists and things is very often we're taking a problem and we're trying to get the computer to solve that problem. So if we're trying to get a computer to solve a problem, what we need is a good idea of what that problem is, an idea of how it works, and how we might want to go about solving it, but also how we think a computer might want to go about solving it. Another thing we're going to teach you is the C programming language. I think I'll talk more about that in detail later, but as I was saying, it's probably one of the most historically significant languages, and I'm just going to throw a ballpark figure out there. I would say at least sort of 70 or 80% of the programming languages that are in existence at the moment are based on C. So it's a pretty good one to learn because you can sort of branch out into all these other... Oh, actually, who's done any programming before here? Holy crap. Okay, that's heaps of people. What's up? Someone was saying something? No? That's all right. So if you've done some programming before, you may have seen some things. I'm just going to throw out some names here. You may have seen JavaScript. You may have seen C#. You may have seen Java. What else? Does anyone else have any other programming languages they started off with? Yeah. Oh, Python. Oh, yeah, totally. Python's a really good one to start with. And a lot of the high school programs are looking at things like Python and JavaScript and stuff like that. Okay, Python, JavaScript, C# and stuff, they're all based on C. So they all have some roots in C, and they've all developed from C in one way or another. So we like C as a good fundamental thing because it's a programming language that gives you some historical significance for all the other programming languages that are in use these days. But on top of that, it works in a particular way that gets you closer to your computer than some of the other programming languages that some of you may have seen before. If you have not done any programming before, I'm not going to make you put your hands up because I know people are shy about putting their hands up if they haven't done any programming before. This course is aimed at your level as well. So those of you who have done programming before, there will be some things that you recognize, and there'll be some things that I'm going to try to teach you that are very specific. There's some things that are quite specific to C, and there's also a lot that I'm going to try to teach you which is about thinking about programming, thinking about problem solving and things, which will be probably reasonably different to what you may have seen before, even if you've coded before. But if you haven't coded before, don't worry. This course is pitched so we can start from nothing and build it up. And if you do need help at all, we do have extra ways of giving you help on things. I will talk about all of that when I talk about the course format. All right, so let's go through. I've got a list of everything that we're doing here, but I've got slides for all of them, so I'm going to skip straight into them. UNSW runs on a 10-week term. I'm not sure how many people have been at UNSW before. I don't know if there's anyone here taking this after transferring from another degree. We had been on 12-week terms before and only 2 of them in a year, but now we have 3 terms in a year with 10-week terms. Starting this year, we have this thing called the Flexibility Week, which is week 6. So it's kind of like a break in the middle of the term. And during week 6, we're not going to be delivering any material that is like 100% necessary for the course or accessible or anything like that. So if you do need to take a break, or say, for example, I've given you an assignment, you have to work on that, you can work on that without necessarily having a huge amount of pressure from also having to work on tutorials and labs and also having to listen to me. You can if you want to. I will probably still be lecturing in that week, but the stuff I'll be lecturing in that week won't be fully accessible material. So, we're going to get some guest lectures in there as well, which will be fun. Help sessions will be running, but I'll talk about what help sessions are later. Okay, so into the bits and pieces that we're going to do. One of them is lectures. You have some experience with lectures already because you've been in one for about 20 minutes now. In the lectures, you're going to have me talking to you about ideas. You're going to have me demonstrating some code to you and things like that. The lecture format is pretty dense. So I'm going to be throwing a lot of ideas at you reasonably quickly. If you don't get everything in the lecture, if it doesn't like sink in straight away, don't worry about it too much. It's all recorded. You can go back and slow it down, or you can go back and speed it up and go through the content quickly. Those kinds of things so that you can catch up if you need to. So don't worry too much if the lecturer is like, holy crap, look at all those details. There's too much stuff going on at once. You can always go back over them. We've got the stream A, which is here in the central lecture block, and the stream B is in the physics theatre and the Ainsworth Geo3 theatres. So stream B is moving back and forth between 2 different theatres. We've got this lecture, which is the Tuesday 9 a.m., and we'll have a lecture every Wednesday starting at 11 a.m. So if you do have any questions, you can use the Slido. I'm going to leave that not visible to you because people are... Oh, you can watch the slide. Yeah, Tom can watch the Slido and ask questions to me if necessary. But you have a question? Yeah.
Do we get to see the lecture recordings for stream B?
Yeah, the question there was, do we get to see the lecture recordings for stream A as well as stream B? Yes, you do. So the course gets to see all of the course recordings. So that's actually quite a valuable thing. It's a good question because when I explain something and you look at it and you say, I don't really get it, I'm not sure where he's going with that, it can actually be quite valuable to look at the other lecture stream and say, well, there's another lecturer here, maybe they explained it in a different way. Because Andrew Taylor and I have different personalities, so we're going to explain things in different ways. He's lecturing right now, actually, over in the physics theatre, telling other people pretty much the same thing as you're getting now. We don't really have any specific need for which stream you go to. If you want to, you can go back and forth between the 2 streams, or you can go to both streams, see who you like the most, and then come back here. Yeah. We do that. We try to steal students from each other, but it's friendly, right? It's no big deal. We work together. So I only have one rule, and this rule is going to carry forth not just in the lectures, but in general through everything. And it's a simple rule, and it sort of applies to all of the behavior that you might have in the lectures. And the rule is that no one disrupts anyone else's education. So I know that sometimes you might want to talk to someone here. You might be wanting to say, hey, what did he just say? Was that important? Like, can you just show me that technique? And I don't mind if you do that really quietly. But if you do it loud enough that a dozen people around you have to listen to it as well instead of listening to me, then you're disrupting someone else's education, right? As I said before, you've got a lot of freedom now. You've got a lot of freedom to do what you need to do. So if you're in a situation where an emergency is coming up or something and you're not sure if you need to answer your phone, I have no problem with you taking a call outside or something like that. You don't have to just stay here and sit here for the whole 2 hours. If you need to do something else, you're in control now, so you can choose what you want to do. The only thing I say is you can't take someone else's chance to learn away from them. So that's the rule. So excessive amounts of noise will be distracting to other people, but I don't mind if you just lean over to someone else and go, what was that? Can you explain that to me? And you just draw some diagrams on the paper in front of you or something. Totally fine. Okay, so what am I going to be talking about in lectures? I'm going to be covering a lot of the theoretical content. So a lot of like, what is this actual thing and how does it work? So how are we going to piece together all of these little pieces of programming and end up with something functional out of it? I will be doing some coding live as well. I think I do have some code today that we're going to do. I'm going to show you how we connect up to our computer labs here and use them to work on things. We're going to be breaking down problems a bit, so we're going to be sort of cutting apart the abstract ideas that go into solving a problem and saying, okay, how do we do that? How do we piece it together? How do we think about these things so that we can get a solution out of them? Other things that we're going to talk about, which personally sometimes I find the most interesting, is what do we need to know outside of raw coding? So raw coding is just like, yes, typing code into the computer, getting the computer to do things. That is a significant percentage of what happens in computer science, but it's probably not even the most important things about what happens in computer science. We're going to talk about a lot of the other things. I don't know how focused people are on getting jobs and stuff yet. It's going to be something that you'll be thinking about a bit more later. But I am going to talk a little bit about what it's like to work with people, what it's like to work for a living and things like that, and hopefully that will be helpful. Yeah. All right, I'm not going to talk too much more about lectures, but anyway, lecture slides, I think I've linked to, that's just a link to the course website, but the lecture slides and the lecture recordings are available via links on the website. Okay, tutorials. Every week you will have a 1-hour tutorial. Everyone should be booked into a tutorial already. I mean, if you're here and you were enrolled, it means you're highly likely to have been enrolled properly, which means you have a tutorial. So it should be in your timetable. Our course website also has the times for your tutorials. In the tutorials, you're in a much smaller environment. So we're looking at a ratio of 1 teacher to about 20 people at a time. A lot of our tutors as well are people who are currently studying at UNSW. So they're just maybe a couple of years ahead of you. They've done this course before. They showed a good understanding what was going on and a good idea about how to transfer that information to people. So we got them to teach you. So, Tom, we have a question? We do have Tute Labs today. So this week is running tutorials and labs. Did I put that in the notice? I can't remember whether I think I sent an email out to everyone last week, but I'm not sure whether I said that or not. I apologize if I didn't. Yes, the tutorials and labs are running today. So I think some of you are having tutorials straight after this. Yeah.
What happens if I can't make a tutorial or I forgot to go to mine yesterday?
The question is, what happens if I missed my tutorial, I can't make it to tutorial? If you need to, you can check out the timetable on the course website and you'll see there's tutorials running all through the week. So if you happen to miss yours, feel free to just go to another tutorial and just approach the tutor at the beginning and just say, hey, I'm not actually part of your tutorial, but I missed mine. Do you mind if I sit in? They will let you sit in the tutorial. I mean, like, as long as there aren't 40 of you trying to turn up to the same tutorial. They will let you sit in on the tutorial. And if there's space in the lab, they'll give you a computer to work in the lab as well. So if you need to be flexible with things, you can be flexible with them. We are going to get this situation later in the term because we've got a public holiday around Easter. So I think we've got a Friday and a Monday public holidays. And so a lot of people are probably going to be going to other tutorials in those weeks as well. So that's totally fine. So as I was saying, we're flexible, you're flexible. Within reason, so long as 100 people don't try to turn up to one tutorial or something like that, we can accommodate if people need to move around. The tutorials are going to go a little bit further into the content that I'm going to teach you. So I will present an idea to you in a lecture, and then the week after that, the tutorial will look into that idea in detail. And because you've got a lower ratio of students to teacher, so you've only got about 20 students per tutor, you can actually ask questions and have a conversation about things. You can work through things. Your tutors will potentially put you into small groups to just discuss things as well. So you may get a lot more out of that. I mean, different people get a lot more out of different ways of learning. Some of you are probably going to learn by listening. Some people are going to learn by doing. Some people are going to learn by discussing. I think one of the most difficult things for people is, like, if you're one of those people that only learns in what we call a performative way, where you have to talk about it to learn, it makes it very hard in lectures. But in tutorials, you will actually get to talk about things. The tutorial questions we'll make available again on the course website. So I'm just going to keep firing you back at the course website because that's where all the information is. The questions for the first tut and lab are up already, but I'll talk about the labs in a second. Actually, right now. So straight after the tutorials, we'll go into a room full of computers, which is one of our computer labs here, and you will get given a series of exercises that you have 2 hours to work on. This coding will be done on our computers. A lot of this will be done in pairs, because what we want you to do is to get an idea of what it's like to communicate with another person about your code. And also, you can teach each other solutions to problems and things. So it's actually going to be a bit easier than just ramming your head against a brick wall of misunderstanding when you've got someone else to talk to about. I've got a little bit of information in here about marks and grades, because I think people are very often wondering about marks and things. The lab exercises will be worth 10% of your final mark. I'll do a full breakdown at the end that shows you exactly how much all the marks are worth for everything. There are also these things in the labs we call challenge exercises. They're purely for interest. So I'm just going to say right out that if you see something called challenge, you can do it if you want to. I can guarantee you that the challenge exercises are, in terms of the amount of time spent for the amount of marks you can get out of them, they're not technically worth it. But if you're interested, there's something that you can do. So if you're looking for something to really kind of burn your brain and really think deep about programming, you can have a look at the challenge exercises. Should point out that you don't need to even attempt a single challenge exercise to get the full 10% in the labs. We're also going to be running weekly programming tests. So as I was saying before, university can be an interesting place. We'll have an exam at the end of the course, and the weekly programming tests are actually really, really good training for the exam. So we're not going to lock you in a room to do these or anything. You can lock yourself in a room. I think everyone's capable of doing that if you try. We're going to run them through weeks 3 to 5 and 7 to 10, so we're not going to run one in week 6. Basically, we'll give a set of questions to you. We're not going to check whether you're doing this under proper exam conditions or not, but we'll be checking how you do in the exam at the end, so we kind of are. You can take an hour to do these and do them without, not exactly, but basically don't connect yourself to the internet while doing them. So don't look anything up, don't look at the lecture slides, don't look at the tutorial material, and just try to do it. And the value of this is at the end of that hour, you'll have a pretty good idea about where you're sitting in the course. So if you solve all the questions, you'll be like, haha, cruising for an HD. Wait, do people know what an HD is? Some people might not, depending on how much you know about university. So the grading system, you get a pass if you get 50 or more in a course. 65 or more is a credit. Credit's good. Credit means you have a full idea of what's going on in a course and you know what's happening. 75 or more is a distinction. Distinction is very, very good. Distinction is you've fully understood everything in the course and you have a good understanding of it, and you're happy to move on to bigger and harder things. An HD is 85 or higher, and HD is kind of reserved for those people who don't feel like having lives or anything like that. Anyway, I kid. I got a couple of HDs when I was a student, but yeah. Anyway, so. Back to advice about studying at university. Going for HDs in all of your courses is, I mean, sure, try it in your first term. And then when you come to your census, you'll be like, okay, I'm going to get a credit in this and this and this, and I'm going to pass this one because that one looks weird. And then you'll be like, sweet, and then you can survive it. Going for HDs and everything and burning yourself out and not being able to finish your degree is like a recipe for disaster, right? So, I mean, like I say, you try it once. Like, don't try everything once. Try some things once, and then see how you go. I mean, sure, there's going to be some people in here who are like, nah, man, I'm going to HD everything I do. And it's like, okay, cool. Some of you will, and I hate you, and everyone else hates you. Anyway, I kid. Okay, so back to the weekly tests. So these are for you to figure out where you're up to. When you're finished the hour, you don't have to stop if you don't want to. If the questions are like still vexing you, and you're like, oh, this is interesting, you can be like, okay, this is where I am in the course right now. I've done my hour. Then I can spend the rest of the week looking up the solutions. Well, don't look up the solutions as such, but look up the ideas about the problems and see if you can solve them. And then you can hand in whatever you've got at the end of the week. One thing we're going to try to do, though, is give everyone this opportunity to get their 1 hour to figure out how it's working, which means we don't discuss the weekly tests until after their due date. So please don't post anything on the forums about them until after the due date. You can talk to your tutor about them, but try not to talk to other people in the course about them because you might spoil it for them. And everyone hates spoilers. Right, someone ruined The Mandalorian for me and I was really unhappy. Yeah, question there? Yes, I will talk about that in a second, but there is a way that you can connect to our lab computers by a system called VLab, stands for Virtual Lab. And yeah, we will be doing the tests via stuff like VLab. We will also be doing all of your labs and things like that. You can do them via VLab also. Yeah, but we'll talk about that in a second. Okay, so the trick is don't spoil it. It's like a TV show. Don't spoil it until everyone's had a chance to watch it. Question up there. The question was, if we take more than an hour, does it count towards our final marks? Yeah, go for it. So the hour is for you. The hour counts to your final marks because how well you do in the hour tells you exactly what you need to study for the exam. You know, and it gives you a chance to, if you do it properly, so if you lock it down and you don't look anything up while you're doing it, then you get a really, really good idea about what it's like to code in an exam environment. And I should say it's not just an exam environment, this is how we code in job interviews as well. So it's like, you know, sneaking in all this professional training in at the same time. So yeah, lock yourself in with no resources for an hour, but afterwards, if you still want to explore those questions, or you really, really want those 5% marks, they're not, by the way, it's not, again, that's not worth the time. But you can do it if you're interested. Yeah, you can finish them off and finish the marks. Okay, we have assignments as well. Assignments are larger scale projects, so they're like an entire program we're going to write. We're going to write 2 of those. The first one is going to be released at the end of week 3 and be due at the end of week 6, so you'll get 3 weeks to work on it. So we've got your labs that we're working on. The labs are going to be due at the end of the week every week, and so your labs can be considered sort of 3-4 day exercises. Whereas if we give you an assignment, we give you 21 days for it, we're going to expect more stuff to happen in that, and also gives you a chance to write a more complete program. So by the end of each of these assignments, you're going to have this, well, from your perspective, this massive thing with all of this code in it that does all this kind of work and stuff. So hopefully we'll get everyone to the point where they're happy with coding to the level where they can actually complete these assignments and get a chance to kind of test everything that I've been teaching you. So the assignments are really specifically written to use everything that's in the lectures leading up to them. The assignment 1 will be worth 15% of your total mark, and assignment 2 is worth 20% of your total mark. This means they're worth a lot more than things like the labs and the weekly tests and things, because they take a lot more work, and they're really a bigger test of whether you can sort of completely understand what's going on. If you have to hand in the assignments late, we take 1% of the assignments mark, not of the courses mark, but the assignments mark every hour off. And so it just sort of drops off a little, just to quiet aside to that. It means that if you're not going to get 100%, you don't actually have to hand it in the due date. You kind of can work late. I shouldn't say that. He has to mark them, so he's like, "What are you doing, man?" Yeah. But so don't worry too much. Don't try to game the system too much. It's just a bit weird. So just see if you can work on the assignments. It'll be good. This leads into help sessions. The assignments are the times that we find people have the most trouble with the course. So these are the times where people are going to have the most difficulties, and they're going to hit a point where there's stuff in the assignment that is hard enough, because some of the stuff in the assignment is harder than what's in the labs, and people hit a point where they're not sure about exactly what's going on. So we have help sessions here, and I think the timetable's nearly finalized for those already. And so we'll be publicizing that on the course website very soon. These are one-on-one consultations. So basically, we will have one of the labs with a bunch of the tutors there, and you can go there and get a chance to talk to a tutor one-on-one, talk to them about your problems. You can even get them to look at your code, and they can suggest what you might need to do with it. Tom, you have a question?
There's a question that kind of implies this. How do I get to the course website? And
Oh.
where's the timetable of tutors and what's it?
The question was, how do I get to the course website? There's a couple of ways. If you're doing a lot of your other stuff on the UNSW Moodle, there's a link from the UNSW Moodle to our course website. If not, this is the link here. If you really want to, you can write down or you can take a photo of this. Otherwise, otherwise the lecture slides have the course website, but you have to be on the course website to see the lecture slides. All right, I'll leave it up there for a second. If anyone wants to take a photo of it, you can then get to the course website, and then from the course website, you can kind of do everything. But if you ever need to, you can always get there via your UNSW Moodle, which I think most people are already aware of. Okay, where was I up to? Okay, help sessions. The schedule's not up yet, but they'll be up soon. So there's sort of differing levels of how much information you get and how close you get to a teacher. So at this point, you're not that close to me because there's there's like 400 people in here and me at the moment. So you're not really going to get one-on-one help from the lectures. Although if you want to, you can always hang around after the lectures. I'll always answer questions after the lectures. But you're not really going to get a chance for someone to look closely at your code in the lecture. The lecture is for me to just deliver as much information as I can to you so that you can use it later. The help sessions is the opposite, the very sort of furthest opposite end of the scale, which is you can go there one-on-one, and you don't necessarily get the breadth of information that I give you in the lecture, but you can get some really, really focused information on exactly the problems that you're having with things. And so I encourage you, if you're not understanding things completely, or you're stuck on certain problems and things, you can go to a help session. You can go to the help session with your with the work that you've been working on for the labs or something like that, and say, look, I don't understand what's going on here. I know I've been to the lectures, but they didn't quite sink in. I've been to the tutorials, and I kind of got it, but I can't get this program to work. You can actually have a chat with someone, and they can help you do things. We're going to be doing some live streaming as well. It's basically just me sitting in front of my laptop doing some coding, but also I'll talk to you about a lot of things. So I'm going to time these. I don't know how many of them I'm going to do, 3 or 4 maybe, but mostly I'm going to time these to happen around the same time as the assignment releases. So when I release an assignment to you, then I will do a live stream, and you can hop on and say, what does that mean when I'm talking about the assignment and stuff? And I'll present to you what the assignment is and how it works, and maybe give you some hints on how to get started, that kind of thing. We'll probably also be doing other things where we do live streams, which is just pure Q&As. So maybe at the end of term, before the exam, I'll try to do one where I'm just like, okay, AMA. Do people know what AMA is? I think a lot of people know what an AMA is. It's called Ask Me Anything. And so we'll get to that point where we've kind of finished the delivery of the course. Not anything, just about the course. But yeah, so you can come to those live streams and ask questions about specific issues you're having and things. It's going to be hard to schedule those because we've got tutes and labs going all the way through the week, so they'll probably be on an evening or something. I think Friday afternoon is a time that we have free, but I don't know how many people want to focus on coding on Friday afternoons. We'll see how we go. If not, doesn't matter. These are all going to be recorded. Again, there's a link to the YouTube page that I'm running them all off on the course website, so you can have a look at that. All right. Last thing, I think this is the last thing we're talking about, what's in the course, is the exam. The exam is going to test pretty much exactly how much you've learnt in the course. So we're going to be testing whether you can program, and we're going to be doing it all within the same kind of environment that you had your labs and things in. We're not necessarily going to let you just Google random things while you're doing it, so it's still going to be testing exactly what knowledge is in your head rather than just like what you can look up. But we'll be asking you to solve a series of problems very similarly to the kinds of questions we're going to ask you in the weekly tests and the labs. Several of the questions in the weekly tests and the labs are exam questions from previous years. So a lot of people ask me about where can we get, previous exam papers and stuff like that. They're actually in a lot of the course content already. So the weekly test is like kind of one of the best places to look at it. So a lot of it is going to be you need to write code, and other parts of it is going to be you need to understand what was going on. So as I said, we're going to teach you things that aren't necessarily just pure coding. They're about how to work with programs, how to solve problems, and things like that. We're going to be testing that as well. We do have what are called competency hurdles in the exam. There are questions in the exam, and I'll talk about that more. I mean, there's really no point me talking about it now because they're about topics I haven't taught you yet. So I'm not gonna go too deep into it, but there are going to be things where we say that if you can't do these things, then we can't give you a passing mark for the course. These are basically they're on the level of some of the easiest lab exercises that we have, but we need it because we need to make sure that everyone can do the basics before we can say you're okay to now enroll in the harder topics. Because if you don't know the basics and you enroll in the harder topics, we're basically like giving you a fail in the future by not giving you the right information now. So if everyone doesn't have the right information here, we think it's better that you do this again and get another chance to get that information before moving on. You have a question there?
So no matter how well you do in the rest of the part of the exam, as long as you can't complete like one of the competency questions.
Yes. So the question was, no matter how well you do in the rest of the course, if you can't complete one of those competency hurdle questions, you will fail the entire course. That is correct. I should point out that if you are doing really, really well, actually, if you're doing very badly in the rest of the course, you can still answer the competency questions. But if, for example, you pay someone hundreds of dollars to do all your assignments for you, you never go to the lectures, and you paid someone else to do all the weekly tests for you and stuff like that, you're going to fail the competency questions because you haven't done any work in the course. But if you've made a genuine effort in the course, and you've been able to do all the lab questions and all the weekly tests, well, not even all the weekly tests, or even all the lab questions, maybe only like a third of them, you'll still be able to answer these questions. So it's kind of a filter. It's nearly a cheater filter. Nearly. Not quite, but nearly. Yep.
It says, are the competency hurdles labeled as such?
The question was, are the competency hurdles labeled as such? Yes. In the exam, we will mark clearly which questions are competency hurdles and which aren't. We'll probably give you some practice on them as well. I know that in our final lab, we usually have a practice exam, and we usually give you examples of some of the easy competency hurdle questions that we have there as well. So you should have a decent amount of practice on them, or if you try the practice on them and it doesn't work out, you'll know exactly what you need to study. Okay, so if we add everything up, it looks like this. The labs are worth 10%, the weekly tests are worth 5%, the assignments between them are worth 35%, and the final exam is worth 50%. So the final exam is really the key, but the final exam just ties together everything else that we've done in the course, and it's a way for us to test how everyone's doing in an environment where you have to do it yourself. So we can really, really tell who it is individually who's answering these questions. To pass the course, you do need 50 or more overall. That's a standard kind of thing at UNSW. We need you to get at least 50 marks out of 100, and then we consider that you've understood the core of what we're teaching. So we taught more than that, but you didn't need all of it to be able to continue or to be able to, for us to sort of put a rubber stamp on it saying, yes, this person understands what's going on. You need 50 to do that. This is for later, because I haven't taught you what these words mean. But the competency hurdles will be based on using arrays and using linked lists. We're going to spend roughly the first half of the course working with these things called arrays and other structures that we use. And the second half of the course, we're going to spend time working on these things called linked lists. Don't worry if you don't know anything about any of these. Super not important yet, but we will talk about that later. Okay. Something that's important to think about is special consideration. So if everyone's coming out of high school, if you had a situation where you got sick and you couldn't do something, you would have a chat with your teacher or maybe get a medical certificate or something like that and say, okay, this is the reason I couldn't, I won't be able to finish this assignment or something like that. There's many other reasons why people might have special consideration. You know, family emergencies, other things you have to do. I had someone win the Australian Pokemon trading card game tournament and then got given a ticket to go to Japan to compete in the Worlds. You can get special consideration for things like that as well. Because, I mean, like, they had to go, right? I said they had to go as well. Anyway, but special consideration can be for a lot of different things, right? It's not just for getting sick. Some people have pre-existing conditions that mean that the way that we assess you is unfair. And so if the way that we're assessing you is unfair because you have conditions that you need some support with, you're totally fine to get some support here, right? In general, it's often better if you're worried to get yourself some special consideration. Because one of the things that we get a lot is people don't apply for special consideration when they should have it. So we see people who are like nearly failing out of the course, and we have a chat with them, and they're like, oh, I can't see the lecture slides properly. And it's like, well, you should have had, we should have been able to give you a chance to do things. So apply for special consideration if you think you need it. Sometimes even if you don't think you need it, even if you're not going to use the extensions that we give you in special consideration, it's good to apply anyway if you have a need, so that if it comes up, your case has already been sort of sorted out. If you have special consideration for the final exam, because the final exam is set at a very specific time, it's going to be during the exam period, which is roughly a week after the term ends. Sometime during that exam period, our exam will be. We're usually near the beginning, but I'm not going to make any promises. If you can't make the exam, you can apply for special consideration and say, look, I can't get there that day, or you were like really sick on the day, and it's like, I don't want my marks for this whole course to tank because I've got the flu and I can't think clearly. So you can apply for special consideration, and then we'll have a second exam called the supplementary, which will be happening in May. I can't remember when our actual exam is, but the supplementary exam I think is a few weeks afterwards. So hopefully if you can't make one, you can make the other. If you want, there is a course textbook that you can look up. I'm going to be real straight with you here. I don't use it because the internet moves faster than paper. That's just the way I think about it. But a lot of people like learning from a very, very structured way. Because I mean, like, the book's going to be way, way more structured than the internet. The internet's going to tell you a lot of things that are flat out wrong as well. But if you want to, and if you want another resource, again, this is the kind of thing where it's like, what you're getting from the course isn't exactly what you need. It's not presenting it to you in a way that you can understand. You prefer reading than listening. Go for the textbook. It's totally fine. We're not going to be using anything specific from the textbook in the course. So this is no way required. Like, no one has to get the textbook. But if you want to, it can be another resource you can use. Right. So the university has a code of conduct all of you have probably signed something agreeing to the university's code of conduct as part of your enrollment, because you can't enroll without agreeing that you are going to abide by the university's code of conduct. The one rule that this kind of attaches itself to in a very convenient way is you don't hinder anyone else's education. So this doesn't just mean being distracting in the lecture. There's other things that you could do that would convince the people around you that they're not worthy of being here, or they don't have a right to study here or a chance to study here. That comes under the code of conduct, and also comes under the whole idea that if you convince someone that they shouldn't be studying computing when they had every chance of doing it, then I'd consider that you were taking away their chance for education. So I want everyone to be treating everyone else with respect here. There's no reason why anyone here can't learn what we're teaching in COMP1511. And there's no reason why anyone here should be able to take that chance away from anyone else. So what I'm giving all of you from this day until the end of the 10 weeks is a chance to learn what we're teaching, and no one is allowed to take that chance away from you. And I think probably more importantly, I would ask you all to not take that chance away from someone else, right? And you don't always realize what kind of behaviors you might be doing that might be causing problems with that. And we've already seen one up on the Slido when someone was commenting on the appearance of the person who was talking about med review. That's not cool at all, right? That kind of thing makes people uncomfortable to be here. It takes the chance of their education away from them. And so I'm not cool with that. The university's not cool with that. None of you should be cool with that. All right. So we're going to have full respect for each other, and that also includes full respect for the privacy of other people. So I know it's really funny if your friend is logged onto their computer and then they go up to the bathroom and you post something on Facebook and stuff like that. Like, let's not do that, right? Because that actually leads to some pretty serious issues at UNSW. So if you're ever on anyone else's computer, then you may end up triggering a plagiarism investigation where we will go looking to see whether you've been working together on your code. You may end up losing a lot of marks out of it, even if all it was you thought was an innocent joke and things like that. So please don't use anyone else's accounts, don't look at anyone else's stuff. And if anyone has things that they consider private, you don't use it and you don't pass it on to anyone else. Speaking of plagiarism, so we need to be careful that when we assess you, we are assessing you and not someone else. So the university is reasonably clear on these rules, but we need to be clear on what we're doing here in the course about what level of working with other people is okay and what level turns it into a situation where you're taking someone else's education away from them. So we could have a situation where one person finishes an assignment and then they give the assignment to someone else, and the other person looks at it, but they don't even use it. They just sort of look at it and read it and stuff. And you might think that that's not cheating because we didn't directly copy from each other, but it kind of is. And it's not actually like, I know a lot of people think it's like, oh, cheating to get more marks, but what it's actually doing is you're cheating that person out of a chance to actually learn what was going on. So it's actually much better to go through an assignment and get pretty crap marks, but struggle all the way through it, because then you'll actually understand what's going on. You'll do better in the exam. It's better than getting full marks in the assignment from something that you didn't actually do yourself, because that's only going to bite you in the ass. Like, it's going to mean that you'll be worse in the exam, for starters, but secondly, you don't learn the content that's here. So I don't know how much people are paying for this. I think it's at least $1,000 or something. So you're dropping is it more than that? It's a couple of $1,000s or something?
It depends on what your situation is, but it's
Yeah.
anywhere from 1K to 5 or 6K.
Yeah, so it's anywhere between $1,000 and $5,000 to $6,000 you're spending on this. So why would you cheat yourself out of learning things? Because the point now is, and again, this is that whole thing, this is that transition from high school to university. Because in high school, you're like, oh my God, I just want to get through this. I want to get through this and get the hell out of here. But in university, you're like, I want to get through this, and where I'm going after this, I'm going to use everything from here, So everything that I teach you here is the kind of stuff you're going to use in your future work. So if you don't get a good handle on it, it's just going to come back later and people go, how do you not know that? You know? So if there's any situation where you could look at someone else's code, try not to. It's actually worse for you to do that, except in cases where we actually do want you to work together. Tom, question?
How does referencing work?
How does referencing work? Oh, I do have something about referencing there, don't I? Do I? No, I didn't, but it's just a question in general. There are a lot of resources you can use online. So there's a lot of websites that will show you tricks on how to code. They'll show you techniques and things like that. If you do use techniques from anywhere online that's not part of our course materials, you should leave a note in your code saying, this is where I got this from. I looked this up and I transferred this from this website and then I used it, and that's where I learned this technique from. So that kind of thing's totally fine, just so long as you do actually acknowledge where you got something from. Do you have a question there? Yep. Question was, is this a comment within the code or a footnote or something? We'll talk about comments later, because not everyone knows what a code comment is yet. But for you personally, yes, comments is fine. Yeah. There's a lot of collaboration that can and does happen in this course, and that's totally fine. So in all of your labs, you'll be working with other people. So you'll be working in pairs the whole time in your labs, to the point where we're actually expecting pairs to hand in the same code. So of course you'll be collaborating there, you'll be talking back and forth about it. And you can talk to other people in the course about the lab stuff as well. That's totally fine. That's the kind of thing where we want you to sort of be sharing and discussing and things. But as I said before, the weekly tests, we don't want spoilers, because we want everyone to get a chance to do the 1 hour of the weekly tests. And assignments are considered individual assessments. So the line that we draw is that you never look at anyone else's code in the assignments. And when you're discussing things for the assignments, you can discuss general techniques, but nothing super specific to the assignment itself. So if you tell someone, oh, this assignment has the need to do this, 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 then this, then what you've done is you've taken away their chance to learn how to solve that problem. And again, breaks the one rule. The one rule being you've taken away someone else's chance to learn something. So the assignments are structured so that you step through them bit by bit. And as you step through them, it sort of unlocks the ideas that you understand how to solve problems. So the more that you talk to other people about how to solve those problems, the more you kind of take away their chance to understand the flow of it. It's basically all about spoilers. Like there's a full story in each of the in all the content that we're doing in this course. And if you give away parts of the story, then the rest of it doesn't make sense anymore to people, and it's sort of like the exercise is lost. Okay. Oh, that was what I was just talking about. Sometimes I'll talk about a slide and forget that I actually had a slide for it. You can go back and look over this slide. This is what I was just saying. Tom, we had a question.
Is there a referencing system we need to use?
The question was, is there a referencing system we need to use? There's no specific referencing system. If you're going to use something, if you just make a note of it, it's okay. We're not doing like Harvard or MIT referencing or anything like that, because we're not really going to be writing reports either. Okay, let's take a break for 5 minutes. I want to show you this little thing here. You can look at it in the break if you want, but I think we've got some people who want to talk to you during the break. It's this little app that has some of the basics of programming in it. It's really funny because it's actually an app for teaching, I think, people aged 3 to 5 about programming. But it's like, hey, the basics are the same. You make this little robot walk around by giving it instructions, and it follows those instructions. You can check it out if you want. Okay, it is 10:08. We'll come back at 10:12-ish. But we've got some people to talk to you here. Yep.
By the way, can you try and log into your Slido account on my computer if you're comfortable doing that? Because it might be that I can just...
You can't... oh, right. Okay, yeah.
If that makes sense. But I think we should get the moderated version. There's no way it makes sense to do that. Is there a URL?
Hang on.
Oh, yeah, you should make anything. CC, lecture, and batch. also a bunch of like small questions that like I didn't want to ask you because it would take too long. But you might want to rapid fire through them after the break.
Yeah.
Sweet. We're just gonna hold it if that's all right with you.
Yeah.
Sweet. Is there like a specific side for CSE Sock intro?
No, they should.
Easy.
I didn't realize.
Nah, that's
Oh,
fine.
it's doing it like this. Okay.
That's all right. We
fine.
can just present or whatever. I'll figure it out. Yeah, it seems fine. Just remind me what I need to say, and it should be all good. That's fine, right? This is how real coders do it.
So what happens when you export a Google Slides to a link?
Yeah, it's
You
fine.
don't have data access?
Alright, I'm gonna try and shout at everyone. Excuse me.
Oh, nice.
Hey everyone! This mic is this mic working? I'm not sure. So, hello everyone. We're both from CSE Sock. CSE Sock is the representative society for all CSE students, which makes this a particularly important lecture batch to watch because there's a bunch of really cool information that's quite important. My name's Tom. I work on the course. You may have seen me down the front, but I'm also the grievance officer for CSE Sock.
Hello, I'm Shrey. I'm the student network director. If you haven't met me already, come say hi.
Basically, what we do at CSE Sock is we try and put on a bunch of like co-curricular stuff for CSE students. So social events, networking events, student development stuff. Basically, anything to do with being a CSE student that's not sitting in COMP1511 is kind of what we do. So let's scroll down. Am I talking about this or are you?
Yeah,
You're talking about this.
All right, cool. So we have our first year camp coming up. It's quite possibly the biggest camp on the uni. Oops. It's a good way to meet people that you haven't met already and interact with fellow classmates in an off-campus environment. Highly recommend going. Tickets are still on sale to the 19th of February. Early bird closes tomorrow night. Yep. So you can go to this link, bit.ly/CSESockFYCamp. It's also on our Facebook page. If you're not following our Facebook page, highly recommend following it to get in touch with all our events.
Cool. Just one thing to note on that as well. When I was at first year, I basically knew no one here. I went to first year camp and I met 100 people who I'm now really good friends with. Would thoroughly recommend it if you're first time at uni, if you want to meet people. Cool. First year group. Another thing that is quite useful if you don't know anyone or you're not exactly sure what's going on at uni, we have a first year group on Facebook. You can join that. You'll meet other people who are CSE first years. You'll get updates about things that are going on. You can ask questions. Really great place to go. Would thoroughly recommend joining that group.
You guys are because
Sorry?
more at it than me.
Sure. The other thing, and again, this one is particularly important if you're in COMP1511, which is everyone in this room, Lab 0. So some of you have already had Lab 1, and you will have noticed that in the exercises, one of the exercises mentions Lab 0. Lab 0 is basically all of the things that we don't teach you in 1511 that are kind of useful. So introduction to the university, introduction to CSE Sock, setting up your computer. It's basically an opportunity for you to meet a bunch of people and get everything done that you can't get done or won't get done in your first lab. Would really recommend coming, especially for the free food.
All right, we also have a Unix workshop for those of you who have done some programming before and want to look at what the terminal does and how it works. That is today from 11:30 to 1. That's in level 5 Ainsworth Studio. So go up to Coffee on Campus, go to the elevator and go to level 5. Yep, so you learn about Unix, shell commands, some other stuff that we don't teach you here yet. We also have peer mentoring. Applications are still open for late entries, so hit up this link as soon as possible, and it'll put you in a group. It's a great way to meet new people, to be mentored by other students by second years, third years, and fourth years. Find out what some good courses are, how to do them, how to do well in those courses.
Cool. That's it from us. If you want to find out more, you can come and talk to me. I'll be around after the lecture, or Shrey. Yeah, cool. Enjoy. Thanks.
Hey, thank you.
No worries.
Are you going to go through the questions now or sometime later? Okay. Oh, and do you want to log into the Slido on my computer? I'm not sure if this will work. It seems like a massive hack, but if it does work, it'll be great.
Awesome. 1, 2. All right, let's get started again. Okay, everyone, can I get your attention again? All right. So a few things I'm going to teach you. Hello. Settle down. Let's sit back down, please. Okay. So one of the things that people ask first, one of the first things that people always want to know about is, how do I do well in this course? And it's a simple idea, but it's not easy to do. And it's the same thing for pretty much everything you might want to learn in life, or anything you might want to get good at in life. There is a correlation between how much time you spend on something and how good you get at it. It's a pretty simple thing. I could have had lots of memes here. I didn't actually put any of the memes in. But, I think there was this meme about someone doing art, and it's like, how do you get so good at drawing like that? Oh, I practice heaps. And it's like, oh, it must be some kind of secret. No, I practice heaps. And it's like, oh, they must be innately talented. No, I practiced heaps. Oh, I'll never know. And it's like, what do you mean? I practice, right? Programming computers is the same thing. The more time you spend on it, so the more time and effort you put into it, the more you're going to get out of it. And that's just the basics of learning anything. We have set up the course to sort of ease your way into it. So we've got a lot of content that sort of shows you something and then ramps it up and then shows you more about it and then gives you a crazy challenge for if you really, really want to go deep into it. So the best advice I can give you if you want to succeed in this course is that there's no tricks. If you do all the content and you try to make sure that none of the content is spoiled for you. So I think one of the worst things you can do is actually search COMP1511 on Google or something like that, because every now and then there's people that put up a lot of solutions to things, and it's really, really bad. Because, I would get them to sort of take down all of their solutions if I could, but there's not much of a way around that. All I can say to you is that more stuff that you get for free, the less you learn. And I'm just assuming that everyone's here to learn. I don't know. I wouldn't spend all my time and money coming here if I wasn't here to learn something useful. So if you want to learn things, take the time to go through the course content. And it's going to be different for everyone, right? Some people are going to need more time than other people. You'll figure it out for yourself. We also have the weekly tests available so that you can see how you're going and you see which parts of the course you think you need to spend more time on. Question, Tom? Oh, the question was, do passes, credits, distinctions, etc. count after uni? No. Maybe. If you're trying to do a research degree after you finish at UNSW, then yeah, your academic marks will count. But usually people don't try to do research degrees unless they were very academically inclined to begin with. In terms of whether Google will hire you to be a software engineer or not, I think they may look at your marks a little bit, but mostly what they're going to do is see what you can do on your own. So they'll put you in a room with one of their engineers and say, okay, solve this problem with me. And then you'll be expected to be able to talk the problem over with the Google engineer and then work through the solution with them. So you can see how they're actually looking there not just at your raw programming ability, but also your ability to work with people and things. It's funny when people talk about getting jobs and stuff. People get more jobs based on their personality than on their technical skills. I have a whole lecture on that, by the way, and we'll be doing that later. But, oh yeah, the other thing, sorry, I nearly forgot this point that I put on the bottom here. Everyone's coming in here at a different level. So there was a whole forest of hands that went up before for people who had done programming before. That's good. It's handy that you've done programming before. Maybe some of this course will be easier because of that. For other people, you may not have done any programming before. That's not going to hold you back. So the thing I want you to focus on, and it's more important what you're learning and how you're learning than it is where you're at. So it doesn't really matter whether you're currently, I mean, like, no one currently is anything yet, but whether you're currently a distinction student or a credit student or anything like that, if you're happy with the content you're getting and you're learning a lot from it, that's much more important. So we always get this idea that, like, you know, someone that knows it, because I've had this before, right? I had students that come in knowing a lot of programming already, and they're probably in here right now and they're switched off. Like, who's on their phone? I can't see, but you know, they're like kind of switched off. And those people are here at the moment, and people who haven't coded before are here at the moment. But what you get is the person who is switched off because they think they know everything already is going like this. They're going flat. They're not learning anything. And then the person who doesn't know anything but is keen is like this. And then there's this point where they meet here. And the person that was learning is really used to learning, used to like processing information and used to getting a lot out of it. And they keep going. And the person that was like, nah, it's cool, I already know everything, I don't need to learn, is just sitting on this flat line. And when they get overtaken, it's like this really like difficult situation for them. They're like, oh my God, I used to be the smart kid. We all used to be the smart kid, by the way. There's just different points in life where you realize you're not the smart kid anymore. It's like no one ever tells their 3-year-old they're not a smart kid, right? So everyone's a smart kid. But some of you made it all the way through high school still being the smart kid. I know, I did the same thing, right? And then I came to uni and I was like, what? I'm the class clown? What? I was the smart kid. Just, yeah. So it's weird, right? Because UNSW in particular is this massive concentration of like uber smart kids. Like, too funny. It's getting too real over here. So you get this kind of thing where you've all come here from all these different high schools and things, and a lot of you were the top of your classes and stuff, but the problem is when we put all these top of the classes together, people feel like they're not necessarily the top of the class. What I want you to think about here is focus on your improvement, compete only against yourself, and that will be the best way for you to learn. Because if you focus on everyone else around you, you're not really going to be thinking about what you needed to learn. You're going to be thinking about what other people know and you don't. So that's just that kind of attitude that can help you get the most out of this course and in general university. So the trick is unlearn what you have learnt. There's a lot of ways that you may have been used to doing things. There's a lot of techniques you may have learnt to get through high school. If you can, see if you can deprogram yourself from all those programming jokes. Sorry. The more open your mind is now, the more you're going to get out of starting this journey into university. I apologize for anyone here who has been at university for ages and is just like sort of transferring across into computer science or something like that, because you probably know all this already. But for a lot of people here, I'm speaking to the majority of the class here who are coming here straight out of high school. This is going to change everything about the way that you learn. It's going to give you the freedom to learn the way that you want to. And hopefully it's going to give you the knowledge that's going to stick with you for the rest of your life. And it's going to give you a career and things like that. So I would hope that everyone tries to be as open as they can to the kind of stuff that I'm going to teach you and other lecturers are going to teach you. All right. Wrapping up sort of the first half of the lecture and everything, if you want more information, the course webpage is a good place to start. If you need more details about how the course is going to run, there's a course outline. And also the course forum gives you the opportunity to ask questions. I think there's only one sort of big thread on the course forum so far, and that's all of us just posting pictures of our pets. So that's just like a little introduction. My cat's in there somewhere, but I think I've lost amongst all the millions of replies. But, you know, you can ask anything on the course forum, except don't spoil the weekly tests and don't spoil the assignments, right? But otherwise, you can ask stuff. You can ask about techniques and about labs and things like that. You can even ask, like, all right, how am I getting set up on my computer or anything? A lot of the times, we will kind of we'll want to ask someone something. And so you might email your tutor and say, look, I need help with this particular thing. Look for the answer your tutor gives you, because what they will often say is, can you post this on the forum? And usually them saying, can you post this on the forum, is them saying, that's a really good question. And because there are 700 of you in this course, I think more than 700 people in this course, someone else is going to have that question as well. So we want to be able to give that answer to the whole course, not just to you. So often when you ask your tutor something, they'll say, hey, post on the forum. This is a good one. Tom, question?
Can I be anonymous on the forum?
Oh, yes. You can ask anonymous questions on the forum. You can also ask invisible questions on the forum that only the subject staff see. So if you're embarrassed about the question you're asking, you can make it private if you want to, and then we will answer it. So I mean, either way, the course staff are the people who are going to be answering, I guess, the majority of the questions, so it'll still get an answer. Oh, by the way, you can answer questions on the forums as well. So if you've noticed something in the labs and things, and you notice someone asking about it, it's okay for you to say, I think it goes like this. So don't worry, even if you give incorrect information, one of us will just sort of go in and say, okay, let's just clarify this. But it's okay to answer questions. Anyway, if you have any other sort of serious issues, this little section at the bottom here, you can email the course itself. That goes to myself and Tom and a few other people. I would only email the course if you've got like an emergency or something, because that's just a few of us trying to answer emails, and so 700 of you email that inbox at once, my inbox explodes, and then a lot of people are not going to get answers. The forum's probably going to be more useful. Tom?
Correct me if I'm wrong, that email
Is that email? Oh, wow. Yes, that email's incorrect. I'm going to change that now. Yes. All right, there we go. That's our official email address for the course. You can use it if you need to. General UNSW problems go to the student nucleus, which is just the sort of first port of call for students on anything. So questions about enrollment, special consideration, anything like that, you can go there. The School of Computer Science has a help desk that may help you with things like getting access to our labs and stuff like that if you need. Often you can go to our forums first, I think, rather than needing to go to the help desk. Tom?
There's a good question about help sessions which I should ask, which is, do I need to book for a help session or can I just turn up?
Oh, the question was, do I need to book for a help session or can I just turn up? You can just turn up when the help session is running, but we do have like a queue system where basically you sign up into a queue and then everyone that's at the help session with certain questions goes into the queue and the tutors will go and answer those questions with people. So you don't have to pre-book for the help session. You can just turn up to get one-on-one help. Just bear in mind that if you turn up to a help session at like 9 p.m. on Friday just before the assignment's due, you might not be the only one there. Getting help earlier is probably going to be better than later. Okay, and I have the correct email address here. Please make sure that your UNSW email address is set up. That is where all our course notices will go. So if I need to tell everyone something, it's going to go to your UNSW email. So either check your UNSW email or, because I think it's all via Outlook, right? You can get your Outlook to automatically forward to another email address if you want to just get it somewhere else. So I think there's some information from UNSW about how to do that. Okay, let's get into actual course content. So the question I put up here is, what is a computer? And that's an interesting question because I can see a few hundred computers from where I'm standing right now. Actually, we can have a fun discussion about whether Macs or PCs are better, and I can see who would say what, but let's not. They're all the same. Yeah, Tom? Oh, no.
Use a Mac or a Windows or what operating system do I need to use?
Oh, the question is, what operating system do I need to use for this course? You can use any of them. It's fine. No matter what operating system you're using, we have a way that you can get into our lab environment called VLab. In your tutorials and labs this week, you'll get a little bit of help setting up. Are we helping setting up VLab in the tutes and the labs? I think we are, right?
Yeah, so we're happy to help with that.
Yeah.
You can also go to Lab 0 where we'll be helping with
Lab 0 tomorrow afternoon is a good time to go and learn how to connect to VLab. If you don't know what VLab is, that's also a good time to check it out. We have a particular computing environment that we're going to be using here you can access that computing environment from any operating system. Right. Question there. Sorry, the question was if you run it on your own computer. No. So the question was, if we want to run all the course content on our own computer, so instead of logging into our environment to use it, you want to run everything on your own computer, will it be really intensive? Will it take up a lot of computing power? No, it won't. We don't need a lot of computing power to learn the basics. In fact, we could do it on a... I'm trying to think of a good example. I don't know. You could do it on a Nintendo Switch or something like that if you really wanted. I'm not sure how, but I know that even on that level of processor, which is basically like a low-end smartphone processor, you could still do it. Yeah. So a computer I like to think of as a tool. It's a machine that can do certain things. And if we were to think of like tools in general, I could think of like a hammer. A hammer has a single purpose. It's there to hit nails into wood, and in doing so, it can join bits of wood together. So it's got a purpose, it's a tool. A computer has a purpose, and it is a tool as well. But one of the things that makes it most interesting is it's not stuck in a single purpose. So it's a machine that can calculate things, but it can calculate many different things, and we can ask it to run different programs. So the programs are the things that we're going to write that tell the computer what it can do. And we can write different programs for different purposes. So I think that's one of the key kind of powers that we're going to get out of a computer is the fact that it doesn't just solve one problem. It can solve many, many different problems. And us as humanity is still figuring out what kinds of interesting problems we can apply computers to. There are two things that we think of that make up what a computer is. There's a thinking bit and a remembering bit. I'm trying to make this as easy to understand as possible. So the thinking bit is what we consider to be the processor on the computer. Anyone heard of a CPU? Everyone's heard of a CPU, right? It's one of the numbers they use to sell you computers. The CPU has this much stuff in it, and it's like, that doesn't mean anything. Sometimes it means how fast it goes, but it doesn't always matter. So the processor, the CPU, the thinking bit, is the bit that understands that we're going to give the computer instructions, and it's going to perform those instructions. At the very, very lowest level, it's just a bunch of maths. It's just a bunch of moving numbers around. But when it gets down to it, it can do a whole lot because of its ability to move numbers around. And the other thing is memory. Memory comes in many forms. You may have heard of RAM. That's also one of the numbers they use to sell us computers. It's got 16 gigabytes. It's probably got 32 gigabytes of RAM at the moment. You go, ooh, wow, it's a larger number than previously. But if you're not using it all, it doesn't really matter. But we're not going to go too deep into all that stuff. Memory is the ability for the computer to store information. So if I'm asking it to do a lot of work, I'm also asking it to remember all the work it's done so it can give me answers back later. So memory comes in the form of stuff like RAM, but also things like your hard disks and things like that that you have on computers. We consider that to also be ways that computers store information. So between those two things, a computer is going to be deciding what to do, processing, and storing information in its memory. And we're going to be working with both of those concepts back and forth through everything we're doing in COMP1511. I want to go back through history a little bit and talk about the history of computers. We think of the first design for a computer being Charles Babbage's analytical engine. It was never built. So it's just an idea, but it was an idea that you could have a machine that would calculate, but it could calculate different things depending on how you set it up. So we consider it to be the first idea of a machine that could be programmed as such. This is a picture of Ada Lovelace. So this is old enough that this predates photography. She was what we consider to be the first computer programmer. So given the idea of the theoretical analytical engine, so she didn't even have this computer, she was writing programs for this. So she was writing the first what we call algorithms. I don't know if anyone else gets excited about this. I always get excited about this. Like someone in the 1800s with no computer was programming. So they just had this theoretical idea that if we were to give something a different set of instructions, it could do things in a different way. And that's all we knew, right? So that's all she knew, but she wrote computer programs anyway. So from now on, I'm going to take all your computers away and make you code. No. We're going to code actual computers. But it's nice to know a little bit of the history of what's going on. This century, there is one person who we think of as kind of, we would consider him the father of modern computing. This is Alan Turing, also known as Benedict Cumberbatch. No, I'm kidding. People have seen that movie. So Benedict Cumberbatch played him in The Imitation Game just recently. It was like 4 years ago or something like that. I can't remember. Alan Turing worked at a place called Bletchley Park in the UK during World War II. And some people, I say some people, us computer scientists like to say that he won World War II. Because everyone who has a particular field they love likes to say that what we did in the field was more important than what everyone else did. But his designs for computers and algorithms was very instrumental in cracking what was called the Enigma code, which was the code that the Germans were using at the time to send messages back and forth to their fleets and their army and their submarines and things like that. And Alan Turing was one of the people that built the systems that learned to crack the code and managed to get it to the point where the Allies could actually read the German communications and thereby start to know where they were going to be before they got there. He also developed a really, really interesting concept, which is called the Turing machine. I'm going to talk more about the Turing machine later when we've got a better idea about how computers work. But the Turing machine is based on the same idea. There's a processor and there's memory. It's a theoretical idea, but it just has these two things in it. It has a thinking bit and a remembering bit, and that's all it is. And that forms the logical basis of all the computers we have today. It actually is the same thing as what all of you have in front of you. So there's nothing that the theoretical Turing machine that he came up with in the 50s? Looking over, when did he come up with the Turing machine? 50s? Or 40s or 50s? Yeah. There is actually nothing your computers can do today that Turing machine couldn't theoretically do. When we go right down to the basic level of what it's capable of, he had that idea already. Sorry? 30s, in the 1930s. So nearly 100 years ago, he had that idea, and we haven't revolutionized that idea. We've advanced on it, but we've not really made huge changes in it. So these are some of the people that are sort of the history of how we got to where we are today. So what have we got now? Now, all of you have in front of you every single, I don't know, we've probably got about 400 laptops in this room. Any single one of those laptops could have swung World War II entirely, because any single one of these laptops has more power than the computers they used to crack the German Enigma code and then crack World War II open. So it's kind of weird that we're not that far on from that, but we've moved on into what we would consider to be like a completely new world where technology is going to, I was about to say rule us and destroy us, but I mean, that still might happen. But technology has the power to do so many different things. So we have the ability to, map weather in real time. We have the ability to try to analyze traffic flow in an entire city, so we might try to correct traffic problems. We have the ability to work logistics to feed entire nations and move food around and things like that. Or we have the ability to, I like this one, to choose what you want to watch next on Netflix based on your browsing history and how long you hovered over particular videos when you were previously surfing through things. So who knows if in this room there's someone or a few people who are going to come up with the next ideas for what to do with computers. I always think it's fun to think about that big picture, because if one of you later on makes this brilliant discovery, I'm going to say I taught them. Basking in the reflected glow, right? So while we are going to be struggling through all the basics of how to do programming, I want you to keep this kind of thing in mind, because the first steps are always the hardest. But then you might get to the point where you're doing these amazing world-shattering things later on in your careers. Okay, so we were talking a little bit about using CSE's resources. So we do have some resources here. We will be running Linux. in our labs, we'll be running Linux for the course as well. So Linux is probably not an operating system that anyone here is particularly using, although I'm sure we've got, I know those two probably are. Yeah, I'm actually running Windows on this machine anyway, so I'm going to run at a level where I reckon everyone else is going to be running it. Also, there's more games on Windows. Linux is a professional operating system, so it's something that's used a lot in industry, but we don't tend to see it very much at a consumer level. One of the reasons it's used a lot in industry is it's very much more configurable than something like Windows. OS X is actually built off a Linux-like structure, and so it is modifiable to a certain extent, but not quite at the level that Linux itself is. So we're going to be working in that because it's a good thing to know about, and it's a good thing to know about in the future, because plenty of companies are working entirely in Linux. There are ways that you can get your own computer set up for Linux. Sorry, I'm just going to move this so that you can see me more easily. It's a robo desk, so I'm just going downstairs. Anyway, sorry. So some of the options that we have so that you can use our systems, the setup that we have for you to start learning in. One of the best ones, if you don't want to do anything like drastic to your own computer, is to use the thing called VLab. So with VLab, we can log into our systems, and what you get in a window on your computer is basically the screen of one of the lab machines. It's not exactly the screen of one of the lab machines, but it will act exactly like one of our lab machines. So you can be in our working environment anywhere, well, as long as you have an internet connection. We have some information on the course website on how to connect to VLab and CSE's resources. You can also set up your own computer. So there was a question there before about setting up your own computer for the kind of programming we're doing. You can do that as well if you want. This is all just differing levels of how deep you want to go. So if you want to get into coding as fast as possible and you just want to get into our environment, you can just use VLab. If anyone is knowledgeable about these things, it's just basically connecting via something called VNC, which allows you to view another computer and control another computer. But don't worry too much about that. If you want to go deep into it, you can set up an environment on your own computer, or you can set up your own computer to be able to do all the coding that we're doing. There is information on the course website under the Home Computing tab there for how to do these things. There's a little bit more information about connecting to VLab on OS X as well. So I see a lot of Macs in here. So if you're on Catalina, there may be some teething issues, but we have some workarounds on the forums.
Page that has the Catalina instructions has been updated.
Oh, good. All right, so you don't need the forum. I think we've updated the page on our course website if you're going to use Catalina.
So if you previously used those instructions on Catalina or on any Mac OS X, just go back to those instructions again, download it, it should work.
Yep. The first help sessions, and also specifically Lab 0, will have a lot of help for getting connected to VLab if you need to. Lab 0 is tomorrow afternoon. What's the time? 2 till 4 p.m. tomorrow afternoon if people are interested. So it should be staggered so that if you want to duck out of, if you're in one of the labs it's at that time, you can duck out for a bit to go to Lab 0. But really, all that we're going to be using in COMP1511 is a text editor and what we call a compiler. I'm going to talk more about what compilers are later. But really, what we're doing is we're writing in text, and we've got a specific setup that has a text editor and a compiler that's going to just sort of make it easy for you to work with. Right. So Linux is what's known as an operating system. An operating system is kind of like the brains that makes your computer run. Because without an operating system, your computer doesn't know what to do. So when we think about it, the computer hardware, you know, your CPU, your RAM, your motherboard, your screen, and all that kind of stuff is just mechanical hardware. Sure, it's like got very, very, very tiny little pieces in it. It can do very complicated things. But without some information about what's going on, it doesn't know what to do. So what sits above the computer hardware and is actually a set of programs itself that runs on the hardware is the operating system. So Microsoft Windows is an operating system, Linux is an operating system, Mac OS X is an operating system. So all of those are things that allow the computer to run. They provide services for us to use on the computer itself. Your code will basically be running on the operating system, which then runs on the computer's hardware. Linux has a terminal, so a lot of what we're going to be doing is going to be typing commands in a terminal to work through things rather than clicking on everything to do stuff. Let me just connect to VLab. I didn't. Oh, yeah, there we go. So I'm just going to do my login here. So your VLab's going to look a little bit like this. If you're worried about how this works, you can just wait until your first lab to get your lab environment set up. A lot of what we're going to be doing is in this terminal. Up the back, is this big enough, the font? Is that a thumbs up? Yep, there's a couple of thumbs up. OK, that's probably big enough, but you can always let me know if it isn't. So we have a series of commands. Let me go back to this that allow us to move around in our environment. So ls lists all the files in a directory, mkdir. So some of this stuff is going to look really silly because the command to make a directory is mkdir. So there's a lot of like funny little abbreviations that are in computing that are sort of left over from the 80s when we were trying to economize on the number of characters that we had for things. It makes stuff like quicker to type in, but it also makes it slightly annoying because you have to remember exactly what the abbreviation was for things. But anyway, we can change which directory we're in, we can make directories, and we can look at where we are. So if I'm here, I'm going to do ls for a directory listing. This is be interesting because you'll get to see my directory. Oh, that's right. I remember. No, I cleaned it up before I showed it. So there's some stuff here that you don't need to know about, which is like COMP1511 in 19T1, T2, T3. So those are my directories for teaching the last 3 iterations of this course last year. But I've got one here, which is COMP1511. Notice I'm not clicking on anything to open anything. Everything's done via commands. So if I want to change directory, I can do cd to change directory to COMP1511. And that will go into this directory. And if I want to, I can do ls. And that looks at what's in that directory. So I've prepared some folders in advance that I was using for setting up the code. I think some of the code's actually available on the website already. If at any point I want to know where I am, I mean, like, it's probably not that hard to know because I've actually got this thing that tells me where I am. You don't have to worry about a lot of this stuff. These are other servers that we use here at CSE that store your things. But the important thing really is like from your name, well, your ZID onwards, you will see which directory you're at. So PWD is going to tell me the same thing, which is like, this is where I am at the moment. You'll get a bit more of a familiarity with this the more you work with it. Okay, so the basics is also gedit and a compiler that we're using called DCC. Oh, I wonder if I had... I'm going to skip over that. You'll look at that in the tutes because I'm running out of time. Okay, so as I said before, programming is like talking to your computer. And the shared language we're going to use to talk to our computer is a programming language called C. So I wanted to at least show you some C before I ran out of time in this lecture, which is I've only got about 5 minutes left. But it's good to know what C is and the way that your computer is going to read it. So your computer is going to think of C as a very, very specific language that works in a very specific way. When I say something in English, I can get half of the words wrong, or I can say something wonky, and wonky isn't even a real word, or I can say there's stuff like this, and and it kind of works. Right? That's actually not that different from how I lecture. But I can say things that don't really make sense. but they make sense to you because we have this kind of shared context, and we have this idea that English works with connotations and ambiguity and stuff like that in a way that programming languages do not. Has anyone had an English teacher in high school who was like super specific, and they would, like, if your grammar was wrong, they just wouldn't talk to you or anything like that? Anyone had a teacher like that? I don't know. Oh, someone did. At least one person did. Your computer is that. Your computer will flat out not understand you if things are typed in slightly weird, right? So we're going to have to learn that this is the way that we're going to need to speak to the computers. The shared language is super specific. Yeah? So it's very clear, it's very defined, there is no ambiguity, and it's quite logical. There are a lot of English words in it, though, so there's a lot of stuff that we can understand without needing to do too much with it. Okay, so I'm going to look at a C program here. This is similar to what it's going to look like in your text editor. We've actually got a lot of these pretty colors in there, which is going to help you to understand different parts of this once you have a better idea about what's going on. So this is one that I wrote partway through last year, and it has some of the basic setup that we're going to use to write code. There's a lot of stuff in here that's not necessarily stuff you need to know about now. There's stuff that we're going to focus on now, and there's stuff that we're going to focus on later. So I'm going to break this down into its parts. The first bit here is what we call comments. So we were talking about comments earlier in one of the questions. Comments are words for humans. So we use particular ways to tell the computer not to try to run some text. So everything that we write, the computer is going to try to process it. It's going to try to think about it and do something. But we can say, don't worry about this stuff. This stuff is for humans. I'm going to say this now, and we're going to go back over it a lot. Half of what you write in your code is going to be for humans. I had an argument with someone before. They said, nah, it's way more than half. A lot of what we're going to do with code is going to be like working with other people. It's going to be working for other people and things. And so we need to make sure that our code is understandable to humans. And because code is not innately understandable to humans, we're going to have to explain a few things. And so that's where we're going to use these comments. If at the start of the line I put 2 slashes, or at the start and the end of something I put a slash and a star, that tells the computer not to read that stuff. So it's there so humans can see it, but the computer can't see it. And so, for example, I have this thing just explaining what that piece of code is. It's a demo program showing output. We'll talk about output in a second. And this is me and when I wrote it. So we're usually going to sign off on our program saying, I wrote this at this time. So it's easier for us to remember when we did something, but also a bit of information about what it's for, so we don't have to look through the code to know why this program exists. We have this thing called include. I'm just going to make this easy for you and say, don't worry about this yet. We'll deal with this later. But I'll tell you what it's doing so that later when it comes up, you know what's happening. What include is doing is it's actually grabbing information from another file somewhere, and it's saying, I'm going to use this code from this other file. And it makes it easier for us to do certain things that we're going to do again and again and again if we just include these files. So this one is tells our compiler to say, grab stdio, which stands for standard input output, which is a library of library is a keyword. We'll talk about libraries later. It's basically another chunk of program that allows us to read information from our user and display information to our user. We got a question? Yeah.
What does the .h mean?
Oh, the .h. We'll get into that later. But for now, it's a way of distinguishing different files from each other. So the .h is a heading file. It's actually technically a header file, but I don't want to go too deep into it yet. But it gives us information about what capabilities something has. Let's not worry about that just yet, though. So this is giving us input and output. And then we have the main function. The main function is something that we're going to be using a lot. Every program in C has a main function. This is the thing that tells your computer where to start. So your computer says, this is where I start running from. And everything inside these curly brackets are instructions. And these instructions are going to be performed by our computer one after each other, going down line by line. So it's going to read this thing and run it, read this next thing and run it, read this next thing and run it. What happens when these things run, we don't know yet because we haven't written any code yet. But What this thing will do is it will do this thing called printf. And printf is something we actually got from the standard input-output library that will send some information to the screen for the user to see it. And then return 0 is the thing that says this program will finish now. And it will say 0 at the end of its finish, which basically is like its way of saying, I'm done and everything was fine. We're not going to worry too much about returns at the moment, other than thinking this is how the program ends. So this program is actually really simple. What it does is it sets itself up, has some information, and then it runs, and when it runs, it just says hello world. So let's look at editing and compiling this. Oh, I've got like 60 seconds left before the recording stops. Okay, we're going to do this quick. All right, here we are. I'm going to change directory to lecture 1, and in here I have this file. I'm going to call gedit on this. Gedit is the program we're using to edit things. Bit awkward because I just went over the line there. But I'm going to run gedit on the file helloworld.c.